Hi again. So today's lesson is our parent trig graphs. It's day 10 of our trig basics unit. After we do some work with our trig graphs, we'll have a big quiz, and then we'll move on to trig applications. So what you need to do for today is take out the graph paper you picked up in class, and what I'm going to show you is how we take those basic values from our unit circle that we know well now, and we unwrap them and plot those points on graph paper. Notice our graph paper is set up so that the x-axis is labeled in radians, and the y-axis is in standard units. So I'm just going to draw a quick sketch of my unit circle just to give me a frame of reference. Really the four main quadrantal points, redefining what a unit circle is, a circle whose radius is 1. So I'm going to go out my 1 unit 4 different ways. We're going to start with sine. Keep in mind that sine is y on my unit circle. So I'm going to be looking at y values. At 0 radians or 0 degrees, the y value is 0. So I plot 0, 0. Up at pi halves radians or 90 degrees, the y value is 1. So I plot the point pi halves 1. And I continue around my unit circle. At pi radians, sine is 0. I plot pi 0. At 3 pi halves radians or 270, sine is negative 1. I plot 3 pi halves negative 1, and at 2 pi, sine is 0. These are nice smooth curves. They are periodic, they do repeat, but this is one cycle of y equals sine of x. That is your parent graph, y equals sine x. Get to know those 5 points by heart quickly. Keep practicing so we can use them in more interesting applications. So let's move on to cosine. Doing the same thing, doing a real quick sketch of my unit circles, 4 major points. And when I get done writing that down, remember that x values are your cosine values. So I'm going to take my x values along my unit circle and plot them. So at 0 radians, x is 1, cosine of 0 is 1, I plot the point 0, 1. At pi halves, cosine 0, I plot pi halves 0. At pi radians, cosine's negative 1, I plot pi negative 1. And at 3 pi halves radians, cosine 0, plot it. And finally back at 2 pi radians, cosine is 1 again. So I plot 2 pi 1. And again I connect those 5 points that you need to know really well with a smooth curve. That is your parent cosine graph. Parent graph is tangent of x. So again, I want you to think about your unit circle. I'm not going to draw it, but think about values along it. At 0 radians, the tangent of 0 is 0. So plot the point 0, 0. At pi halves radians, tangent's undefined. So there I get to draw a dotted line, or an asymptote. You've seen those before. We're going to see them again now. Tangent of pi is 0. Tangent of 3 pi halves is undefined, so there's another asymptote. And the tangent of 2 pi is 0. So that's pretty uninteresting right now. We need to come up with some other points in between. So let's go halfway between 0 and 90, or at 45 or pi fourths radians. Tangent of pi fourths is 1. We can plot that. At 3 pi fourths and at 5 pi fourths, we know that tangents negative 1 and 1 respectively. And at 7 pi fourths, we know that the tangent is negative 1. So we connect these with smooth curves also, approaching the asymptotes or moving in between those asymptotes. A lot of students say that they think tangent looks like x cubed, and it does. Between the asymptotes, tangent certainly does look a little bit like x cubed. Alright, so there's your third parent graph for the night. What I'd like you to do next is open up your Inspire document called the Unit Circle Unwrapped that you got in class today, and just play with it a little so that you can see another way of unwrapping this unit circle. So if you go to page 1-2, you'll notice that you have an up arrow. Just keep clicking on that up arrow and watching what happens with the circle and with the angle measure down below. Here they're taking y measurements, heights, and they're measuring them from the unit circle and then plotting them off to the right on the x-axis. We used to do this with spaghetti, with uncooked spaghetti in the old days. We would measure and break. But now that we have technology, we can do it in 2 seconds. And what it does is it shows you those lengths, those y heights transferred over, and there you get your sine curve. You can do the same thing on page 2.2. Here, though, we're looking at x distances. So what I want you to do on your own is push that up arrow and go through and see how I can unwrap my cosine curve. That's it. Have a great night.